I grew up in Israel, and my hobby as a teenager was windsurfing in the Mediterranean.
This is Ori Zik, physicist and CEO of an energy equipment company called Qnergy. But back in the early 90s, he was a physics PhD candidate just outside Tel Aviv, windsurfing between classes.
But those beautiful Mediterranean waters where Ori spent his free time were facing an immediate threat.
So there was a company in Israel that had scheduled to dump toxic waste in a spot in the Mediterranean. One morning, as the ship was leaving the port, we all jumped in front of the ship, and eventually the ship gave up and went back to shore.
And it was this experience, this environmental standoff, that gave Ori a new sense of direction. He wanted to be a scientist who worked to improve the health of the planet.
For me, especially trained as a physicist, it was more about how do we provide solutions.
It was around this same time that Ori was sitting in class, listening to his professor talk about coal mines.
Imagine 1816, and you're in Scotland, and these coal mines were very unsafe and very polluted.
In the early 19th century, miners would work long, strenuous days, blasting away at the earth hundreds of feet below the surface, a process that results in a lot of excess groundwater.
One of the challenges was to pump water out of these mines, and the practice at the time was a very primitive steam engine. And these steam engines had like a boiler.
The boiler would occasionally explode, making conditions in the mines even more hazardous.
Enter an inventor named Robert Stirling.
This guy, Robert Stirling, was a clergyman, but a very talented engineer, and he wanted to protect his community and find a new engine.
Stirling had an idea. He developed an air engine, which eventually became the Stirling engine. And it's more or less what it sounds like. Air in a container that, upon exposure to hot and then cool temperatures to make it expand and contract, would move a piston and power an engine.
Just imagine those trains in Western movies when you see like this, something goes up and down and then there's a wheel rotating. It worked the same way.
The periodic motion of that piston moving back and forth, powered by just enough heat, would pump water out of the coal mines without running the risk of causing an explosion. And compared to a steam engine, it emitted only a small amount of pollutants like CO2. Plus,
later it was found that if you can attach a magnet to the periodic motion, you can generate electricity.
An engine that's self-contained, less polluting, and can generate electricity. Now imagine powering your home with one of these, or a whole city grid.
So we've built a few prototypes. There were a few that were used, but then it was abundant.
The Stirling engine was only used in a few coal mines back in the 19th century. The engine was abandoned, like Ori said, because apparently it had a lot of issues. It would break constantly and need repairs. It was expensive to make. Problems that made it difficult to scale. So the Stirling engine was mostly lost to history.
It wasn't even discussed. It's not practical. Let's move on with our lives.
Ori did move on with his life. He built a career as a clean tech entrepreneur.
And then one day, over a decade after he'd first heard about the Stirling engine in class, Ori got a phone call. It was from a company named Qnergy, and they told him they'd built a Stirling engine that actually worked. He was skeptical,
but he knew he had to see it for himself.
It's very emotional to see this, it's actually working. It's amazing.
Because as the dual climate and energy crises continue to evolve, the energy transition, the shift from fossil fuel-based systems of energy production towards renewable energy sources, is more crucial than ever before.
I'm Elise Hu.
And I'm Josh Klein.
And this is Built for Change, a podcast from Accenture. So Josh, the challenges facing the oil and gas industry have been years in the making, right? But it seems like the pressure to take this transition from fossil fuels to renewable sources of energy seriously isn't just simmering in the background anymore. It's really reached a boiling point.
Totally. You can't avoid it. And companies are realizing that, they need to take the energy transition seriously just to stay relevant. So they're investing in things like solar power, wind power is expanding.
Yeah. And we're seeing all these promising solutions on the horizon. But making them work means that companies have to totally reinvent their enterprises and the way they do their business.
Exactly. So today we're talking about how companies will tackle the energy transition over the next 5 to 10 years. Basically, what do we need to do today to ensure that we have an energy secure and also sustainable tomorrow?
I grew up in a developing country, and I saw firsthand how important energy is to global and human prosperity and development.
This is Maqsid Ashraf, Chief Executive of Accenture Strategy and a member of Accenture's Global Management Committee.
It's a known fact that almost 1 billion people around the world, 800 million at least or more, have no access to electricity.
And on top of that, Maqsid says about 3.5 billion people only have access to energy options that pollute the environment around them.
I also saw a lot of challenges, right, in indoor or household air pollution. Taking millions of lives in that region was something that I found it hard to reconcile in the world we lived in. I saw how that impacted progress for the population in that part of the world.
Maqsid wanted to be part of the solution, to help people in the developing world get access to energy that would remain stable in the long term. So he moved to the US for college and eventually started consulting within the energy industry.
I was committed to being part of solving the problems that come with the provision of secure, clean, reliable energy. And that is really what has kept me going.
So what exactly does it mean for energy to be secure?
So energy security is reliable, i.e. continuous or uninterrupted, and affordable access or availability of energy.
And that access to energy correlates to economic prosperity. A farmer who can easily find fuel for his truck can more consistently transport his crops to a market and make a living. Energy access is a global necessity, but that said, it's important to find sustainable ways to achieve it.
A secure and sustainable system go hand in hand. To be able to achieve energy security or energy sustainability, you have to be able to ensure that the provision of that energy is affordable.
This is the heart of the tension in the energy transition. Energy demand is growing, and at the same time, so is the urgency to go green. Promising solutions like solar power and offshore wind farms are already improving our efficiency, but more investment's needed in these areas, and deployment at scale if we want to achieve net zero emissions in the coming decades. So, what else can be done?
There's a lot of discussion around the energy transition. We have an enormous energy system with a lot of supply sources, diverse supply sources available.
Diverse sources. The idea being, if a population relies on oil alone, and then the supply of oil is disrupted, prices will go up, and some could lose access to energy. But beyond diverse sources, it's also important to have a mix of sources that are all simultaneously reliable and low cost.
And sustainable energy transition is one that ensures that there's adequate diversity in supply sources, but there is also the ability to afford it such that the global populations can afford any kind of energy.
And Maqsid says, if we can make that transition as smoothly as possible on a global scale, then come 2050, we could actually hit the mark on emission reductions without compromising anyone's access to energy. But to do this means transitioning systems like power plants and grids that currently rely on fossil fuels, and increasing investment to add renewable and sustainable energy sources to power those systems.
We're seeing a lot of that happen more aggressively in Europe, investing in renewable natural gas or biogas. They're investing in the electrification of transportation sector in the form of infrastructure and charging points.
And in the process, funding the technology that'll make the grid more sustainable while continuing their operations to keep access to energy secure.
There are companies, very few, that actually made a complete pivot from being oil and gas centric company to moving complete into offshore wind. Hydrocarbon is still going to be important to the energy mix. Today, it's 80% of the energy supply. You know, the most practical projections still put it as 50 to 70% in 2 or so decades.
Maqsid says that because of the high demand, hydrocarbons aren't going away, and they'll be essential to these interim solutions that we've been talking about. But the biggest projected areas of growth are in solutions that get us to a greener planet fastest. Solutions like renewables, hydrogen, and biofuels.
A big sticking factor is the amount of investment that's required. Today, what we find is even the most progressive players are spending in the high single digits to the low double digits of their capital expenditure in low carbon.
That includes investments in wind, solar, carbon capture technologies.
They've talked about increasing that to 25 to 50% by the end of the decade, but that has to be accompanied by investments in hydrocarbons, which are also lagging and are a threat to availability of energy in the developing world. We have estimated that in sectors like carbon capture and even hydrogen, those markets will become multi-trillion-dollar markets by 2050, and that starts to rival the $3 to $4 trillion, oil economy, if you will.
That means for energy companies, not only is it the right thing to do, but there's a lot to gain.
There's 28 or so years to 2050. You'll have to set some short and medium-term targets so you can see and measure what you're trying to manage, which is a path towards net zero.
Meaning, instead of thinking in the short-term, shareholder profits next quarter mindset, companies have to reorient their vision to meet long-term goals over the next several years. And if they do that, they'll see steady gains for decades and make it clear to stakeholders and the public that they're serious about making real advancements towards a more secure and sustainable future.
There's no silver bullet. No one company, no one industry, no one country can actually really solve this problem. Each company has to think about its role in driving forward the change.
Gosh, Josh, as we got into the details of the transition, it really gives you an appreciation for how complicated the problem really is.
Yeah, I mean, this is a global energy system. There's a lot of moving pieces.
Yeah, I'm sure. This transition could really disrupt a lot of lives if we're not careful about how sustainable energy sources are folded into the mix.
True, we got to be careful. But at the same time, if we keep doing things the way we have been, we're not going to hit any of our targets.
Sure. It seems like the innovations that are going to push us toward our energy future, the fastest are going to be the ones that are able to balance energy security with sustainable solutions. Got to have both.
Yeah. So for that, let's turn back to Ori Zik. When we last heard from him, he'd just gotten a call from a company called Qnergy about the Stirling engine, an idea for greener energy that had been lost to the history books. They confidently told him that they'd created a reliable Stirling engine, and they'd used it to power a generator. But they needed Ori's help.
Just said, look, we have a Stirling generator company, but there are some commercial challenges, like how do we bring it to market? What do we do to scale it? When I came in, first of all, I saw an operative Stirling generator, which was like, it's almost like a physical experience because you see this scuba tank, you touch it and like it's like touching a speaker, you feel this little vibration and then it creates power.
The original Stirling engine's piston, which moved up and down, was attached to a wheel, which rotated to generate energy. Rotation meant more friction, so the machines broke down easily and weren't very reliable long-term.
The Stirling engine in Qnergy is what's called a free piston Stirling engine. Namely, it's all linear. There are no rotating parts.
Instead, the piston is suspended on springs, so it can run continuously without the risk of wearing down. Combine that fix with the modern-day affordability of precision manufacturing options like 3D printing and laser cutting, and Qnergy was able to build these engines sturdily and at scale. But here's the real kicker. Very much unlike traditional combustion engines, the Stirling engine only emits trace amounts of pollutants into the air. It's 100 times cleaner than a conventional engine. In fact, it actually eats up one of the most dangerous pollutants on Earth.
The carbon dioxide molecule stays in the atmosphere for a long time. It's pretty stable. On the other hand, methane, CH4, is less stable in the atmosphere.
Methane doesn't stay in the atmosphere as long as carbon dioxide, but over the course of 20 years, a pound of methane has 80 times more warming power than a pound of CO2. Around 25% of today's global warming is driven by methane. And in terms of the energy transition, limiting methane at its source has been a very complex problem to solve.
You can think about livestock, a huge source of methane.
Food waste from restaurants, kitchens, cafeterias.
Landfills, the same, you have decayed organic waste.
Also rice fields, wastewater treatment facilities. Natural gas wells probing for fuel often leak methane into the atmosphere during the exploration process.
The challenge is that all these distributed sources doesn't have a solution because it's too small to actually build the power plants around it or refine it, but too large to ignore.
But methane makes up the natural gas that powers our gas stovetops and heats our homes, and with the right technology, it can generate electricity.
If you channel methane from emission to utility, if you can use it for electricity, it's a pure benefit. Imagine that you run a natural gas facility, you don't have electricity, but you have the pressure of the natural gas that comes out of the ground.
Now, in order to control the flow of gas on the site, you need to run an air compressor, which helps to control airflow and prevents any excess gas from leaking into the atmosphere. The problem is that these facilities are usually in pretty remote locations, far off the grid, and air compressors need electricity to run. So, more often than not, they'll opt for a conventional generator, the kind with an internal combustion engine, which, as we know, is costly to maintain and produces excess CO2.
Now the question is, how do you power air compressors on the site without paying a lot for maintenance? And that's where the Stirling engine comes into play.
Remote methane-powered electricity, using a naturally occurring and abundant, but polluting, energy source to generate clean energy. And it has uses beyond natural gas extraction sites. Think animal waste as fuel. Qnergy recently ran a pilot at a pig farm in Mexico.
This pig farm was very, very polluting, to the extent that the smell was unbearable. They even got a fine from the Mexican EPA to clean it.
The farm installed something called a biodigester.
Just plastic sleeves on the ground. You feed them with the animal manure on one side, and then it flattens out, and then bacteria digest the manure into methane.
And then that methane gets fed into one of Qnergy's Stirling generators, turned into clean electricity, which then powers everything from lighting to machinery on the farm. And on top of getting reliable clean energy to remote parts of the world, Qnergy's generators are resilient to a changing climate too.
One of our first generators was installed in Louisiana in a very swamp area. This generator suffered 3 hurricanes.
Ori says that after the first one, his team was surprised to see that the generator worked through the whole storm.
The second one, our engineers actually noticed that the efficiency goes up because the hurricane is very good at cooling the radiator.
So by the third time the hurricane swept through, they were pretty confident that the engine could handle it.
I hope there won't be a fourth, but I think that it will survive.
The reality is, climate change and extreme weather have a serious impact on our energy systems. So the more solutions that help keep the grid secure, the better. Because when it comes to the future security of our energy supply, we need to combine sustainable goals with practical solutions.
Although it's a 200 years technology, we're just at the beginning of its innovation cycle.
So everything old is new again. It took 200 years, but that Stirling engine, it finally worked.
Yeah, and Qnergy's powering it by cleaning up a pollutant, right?
Yeah.
I mean, I had no idea that manure could be a source of fuel like that. That's a diverse energy source.
And there's so much of it. And in the decades to come, making sure that we pull from all those diverse energy sources is only going to become more imperative.
Exactly. So now we're going to go talk to an energy company that's made it a priority to diversify their portfolio by investing in sustainable technology.
I started very young, being in the energy industry.
This is Luis Cabra. He's the Executive Managing Director of Energy Transition, Technology, Institutional Affairs, and Deputy CEO at Repsol, a global energy company based in Spain.
The interesting thing is that when I started, it was more a concern about energy security, the price of energy, etc. Maybe by the end of the 20th century and the start of the 21st century, we started to speak about climate change.
In 2003, Repsol was the first major energy company to endorse the Kyoto Protocol, an international treaty to reduce greenhouse gas emissions. And they began to plan how Repsol would navigate the energy transition. One of the first steps was to get everybody on board.
As soon as in 2011, we started providing economic incentive to all of our employees if we reached certain objectives of carbon CO2 emission reductions. We need to reduce the volume of oil and gas that we are producing and processing in our refineries, and we can transform our refineries to different type of fuels.
And so this oil and gas company began to think about how they'd evolve. How would they expand their offerings to include things like renewable power and renewable fuels? Well, as time went on, other oil and gas companies began to talk about sustainability, but customers became weary that there was going to be a lot of talk and little action. Repsol knew that in order to navigate the transition, they needed to make progress in a way that was measurable, accountable. So they set a goal.
We should try to be neutral in emissions, net zero emissions by 2050.
But they knew they couldn't get to net zero overnight. In order for the business to be healthy enough to meet that goal, the transition would have to be methodical, a process of reinvesting, re-innovating, and collaborating to shift over time.
This is based on our conviction that we can make a good business out of the energy transition, which is absolutely what we are for in a company. We need to make our shareholders happy. We need to make this transition as quick as possible, but without big disruptions. This is really a request from shareholders. This is a request from society. You know, we are in a sector that we are sometimes criticized that we may be greenwashing ourselves because, well, we are producing oil and gas. So the single way of proving that you are committed to that is to put interim targets.
For example, the company established a goal that they begin to invest in producing renewable energy. And at the time they made the commitment, they were producing 0 gigawatts of clean power.
We were not a producer of electricity at that time. Now we are producing 1.6 gigawatts, 1,600 megawatts of sun and wind electricity. Now our target is 6 gigawatts, moving from 1.6 today to 6 gigawatts in 2025.
Luis says they're set to grow those numbers too, with wind and solar farms on 3 different continents. And in order to meet those interim targets, they have to keep innovating. So the company's prioritizing investment decisions to focus on developing new, sustainable technologies.
We like to say is our mantra, internal mantra, do not prohibit technologies. Just prohibit CO2 emissions and leave technologies to complement, complete, innovate.
For example, Repsol has an innovation lab.
We have, I believe, now 250 scientists and technologies working there.
Working on ways to use renewable energy from the sun to create hydrogen power.
We are working very much on the different technologies that transform organic residues into liquid fuels.
That means taking excess cooking oil and waste from the agricultural industry and turning them into a lower carbon energy option. But Repsol is also aware that they don't have the capital to fund the necessary research alone. So they joined forces with their competitors to collaborate on funding technology research that'll make these lofty goals possible.
That's really driven by CEOs with a decision to put money together and to invest in technologies, invest in startups, specifically addressing all investment related to reducing the carbon footprint of our activity.
And Luis was clear to point out that these targets are inextricably intertwined with the future of Repsol's business.
Now we are going to grow in something different. We don't need to grow in oil and gas production. We can focus on keeping and improving our best barrels of oil and our best volumes of gas. And the ones that we make, we can produce with lower carbon impact and carbon footprint. We need to, let's say, stretch ourselves every year and see whether we can do things better and faster. Because our conviction is that if the world can transform the energy system in an economic way faster because of technology, because of regulation support, in a way which is practical and effective, this will happen.
Josh, I love talking about the future of green energy, but it often seems so far out. So it's been nice in this episode to talk about the near future, what exactly we have to do to get there.
Yeah, especially given how much is on the line, right?
Yeah.
I mean, we are literally betting our children's future on the stuff that we're talking about today.
Totally. Yeah, companies need to invest, think through this transition, keep it sustainable and balanced, and then also innovate for solutions.
It's true. That stuff's important for businesses' survival, too.
Yeah.
So, to learn more about the trends in today's episode, check out the Energy Transition Report at Accenture.com/built-for-change.
Big thanks to Accenture's Muxit Ashraf.
And to Ori Zik and Luis Cabra for talking to us.
Built for Change is a podcast from Accenture.
More episodes are coming soon. Follow, subscribe, and if you like what you hear, leave us a review.